Alright guys, central limit theorem, focusing just on the distribution of sample mean problems. This handout that I'm going to work in this video is uploaded to the handouts folder on Blackboard. So you may want to pause the video and get that printed out and go from there. All right, it's up to you. So got a couple of problems. One problem on the back, one on the front. So engineers must consider the breadths of male heads when designing motorcycle helmets for males. Men have head breadths that are normally distributed with a mean of 6.0 inches and a standard deviation of 1 inch. These results are based on a survey from those guys, those people. So number one, if a male is selected at random, then what is the probability his head breadth is less than 6.2 inches? Now, if a male, to me, guys, that indicates n equal 1. So the central limit theorem isn't even required to work this problem, but in StatCrunch, it's pretty much worked the same way. So, so let's see. I think what I want to do, I want to go split screen here. And come over here. And so what we would do is go to Stata, go to Stat, go to Calculator, go to Normal, and we'll work the problem this way. So let's see, the mean looks like it's 6. Standard deviation is 1, and we want less than 6.2. Compute. So the answer would be 0.579. All right, the next problem. The Safeguard Helmet Company plans production runs of 100 helmets at a time. Describe the distribution of sample means. Well, we start out with a normal distribution. We have a sample size above 2 and safely above 25. So the distribution of sample means will be normally distributed. How will the distribution compare to the distribution of men's heads breadths? Well, it'll be taller and narrower. That's directly from one of my videos, one of the previous videos. Calculate the probability that 100 randomly selected men will have a mean head breadth of less than 6.2. Well, guys, since we're taking our sample 100 at a time, then the central limit theorem kicks in. But the only thing that changes, the mean stays the same, but the standard deviation will change to the square root. The sample size was 100. And it says less than 6.2, so we're set. So the probability would be 0.977. Calculate the probability that a sample mean will be more than 0.2 inches from the population mean. And I'm assuming, it's not really clear here, but I'm assuming that the sample mean is calculated on a sample size of 100. That's what I'm going to assume. Now, what happens here is essentially what you're asking is you've got your population mean mu x bar, and you're wanting to know the probability that a sample mean will be more than 0.2 inches from the population mean. Well, we could go up to mu sub x bar plus 0.2 inches. And we could go to mu sub x bar minus 0.2 inches. But because of symmetry, we know if we find one of these areas and then just multiply it by 2, that we get our answer. So essentially, what do we need? We want less than, well, we know the mean is going to be 6. So we need 6 minus 0.2, which we know is going to be 5.8. So we need 5.8 and below and 5.8 and above, as long as we get everything set correctly. So again, mean is 6. Standard deviation is reported as the standard error because we have 1 divided by the square root of 100. Because again, that's what I'm assuming in this problem. So I need less than 5.8. So I have 0.0228. Now, just to prove it to you that this is going to be greater than 6.2, is going to give you the same amount, same value. All I have to do is just take the 0.0228 and multiply by 2. And what do I get there? 0.0456 would be the final answer. All right. Back page. It's going to be a quick video, isn't it? Women's heights are normally distributed with a mean of 63.6 inches and a standard deviation of 2.5. So I know that mu is that value and sigma is that value. Because again, it's describing a population. If one woman is randomly selected, then what's the probability her height is greater than 62 inches? So mean is 63.6. Standard deviation is 2.5. Don't have to divide by anything because I'm just looking at one woman. So height is greater than 62. Compute, we get our answer, 0.739. Guys, that's a 9, by the way. It's kind of an ugly 9. Make it a little bigger. Now, if 36 women are selected, randomly selected, then was the probability their mean, their collective mean, is greater than 62. So guys, the only thing I need to do is come in here and divide by the square root of 36. I could have just divided by 6 and compute. And this is going to happen almost every single time. All right, gang, that's it. Short video. Enjoy those when you get them. Take care.